GM guys, good morning. Welcome to another session of the Filecoin Basic Arithmetics. Basic Mathematics at the ongoing Filecoin Bootcamp. It's a pleasure to be here again. It's great. I hope you can hear me clearly. As a follow-up from yesterday when we looked at the cost of actually storing, 2 days ago, when we looked at the cost of actually storing data on Filecoin. Today we're going to go to the other side of the street in terms of the miners, right? So today we're going to try to understand the basic, of course, the arithmetic behind the proof of replication, and then some of the storage-based consensus on the miner side of things. So yeah, let's go. All right. A simple overview. Um, all right. So a simple overview, a reminder, of course, about Filecoin. Filecoin is, of course, a decentralized, it's a peer-to-peer network that allows for storing data on the blockchain. And of course, we also have the storage providers, and then these are the miners, right? So basically, what they do is to be a miner, right? So you have let's say you have some hardware and then you have some space on your hardware, you have a lot of memory. Typically, Filecoin, for every sector, this is what they call sector. So every sector allows for, I think, between 32 and 64 gigabytes. So if you have like 32 gigabytes or 64 gigabytes of space, you can commit that to the Filecoin storage. You can commit that to the network. And then, of course, this would allow you to be able to, of course, generate your proof of replication, meaning that you have committed a certain amount of space to the network. And then on usage of this space, of course, you get incentivized. So we also look at proofs, like we said, the proof of replication and then proof of space time. So remember that when a user stores data, this data is usually over like a period of time, right? So the proof of space-time is actually a proof that the space you committed to the network, you are actually using it to store data. And then, of course, each data is uniquely stored. So you can be incentivized based on the amount of space and data you stored over a period of time. Yeah. So, like I said, basic concept on the minor side of things, we talked about sealed sectors, right? So, like I said, sealed sectors is like when you have your when you have like a hardware and then you have space, like typically the encoding is between normally it's either you are giving like 32 gigabytes or 64 gigabyte, but you could give more, meaning that for instance, if a sector is a minimum of like 32 gigabytes, right, and you have more space, so you can actually give 5 sectors, 10 sectors, depending on like um how much space you have, right? So normally a typical sector would ideally be between, I think, 500 gigabyte to 1 terabyte. I need to confirm that, but it's usually within that. So you can actually provide as much storage as you can, as anyone also can contribute to the network. So the core concept we'll look at is the seal sector, which is when like a miner or a node provider commits some space or some memory to the network. And then we'll look at the proof of replication. Basically, it's a proof that says that you're actually storing a unique set of data, right? You're not just copy pasting the data and claiming that you're storing all of this. So for every data, it's uniquely stored. And that's where we have every time you commit, like once you commit space to the Filecoin network, right? So that act allows you to actually seal a sector. So any data that is stored on that sector, right, generates a proof. And then this is the proof of replication that actually determines that, okay, you committed space and this space is being used, right? And then there is this proof of space time, as I explained earlier. So with the proof of replication that determines that you're actually storing data, the proof of space-time basically is saying that, okay, it's a recurrent thing, right? So it's actually always checking to ensure that a miner actually stores data over a certain period of time. So I think those are the three basic concepts we're gonna look at. And then yes, the Falcon sector, right? So It's a fundamental storage unit. Basically, I've explained it like thrice or now. So you can store between 32 GB bytes. Remember, GB byte is different from gigabytes, right? So GB byte is actually measured is a binary unit. Meanwhile, gigabyte is more of a decimal unit, right? So please always try to note the difference between the two. So basically, gigabyte is I think 10 raised to power 1024 times 10 raised to power 3 will give you like 1 gigabytes in bytes, right? Meanwhile, for GB byte is actually I think raised to power 9 or so, while decimal is raised to power 30. So of course, the sector size, like we said, you can contribute your hardware typically in 32 or 64 spaces, but you can contribute more, right? And then, of course, this allows the sealing process, which is the committing. So this is usually referred to as committing. So once you commit a sector, right, it's kind of like sealed available that this sector, right, is available for usage, right? And then any data that is stored in this sector, it generates a unique proof, and then that's what we have the proof of replication. So every data that is stored on that committed sector generates a proof, and then the proof of space time actually tells how long that data has been stored for. And then miners can commit sealed sectors to the Filecoin network, and then this will prove that they are actually dedicating storage. So we'll look at the types of miners block. There are basically two types of rewards for miners on Filecoin. Right? Yesterday we talked about when people store data, that's more of the market fees, where they actually generate revenue or they get incentivized for committing a certain amount of data. We also have the block subsidy. This has to generally do with people that basically add blocks to the network, right? So this block, the field is actually minted to these miners. It's kind of like what we have in Bitcoin, where we have the Bitcoin halving. So these incentives for adding block, the block subsidy, is actually is a fixed or decreasing subsidy, meaning that just like when just like the Falcon tokenomics allows for field to regulate how much how much a user gets to pay in terms of price of storage per day based on the current value of field to USD, right? So it's kind of like similar on the miner side for those that contribute adding blocks to the network. So let's take a look at how all of this is calculated, right? So basically, the miner's reward is calculated based on the amount of committed sector. That's just the overview of it. So the amount of committed storage that you commit to the network over a certain period of time, as long as you are generating proofs for this storage, determines how much incentives you generate, right? So the rewards are actually proportional to the compute power or storage power rather contributed by the miners, and it's measured by seal sectors, right? So if you have like maybe let's say you have like 500 gigabyte of space, and then you are contributing your maybe 64 gigabytes to every sector, and then maybe you are contributing to a lot of sectors in your 500 gigabytes. So at the end of the day, a certain you're incentivized based on the amount, the percentage of the committed sector that you contribute to the ecosystem. Here I'm talking about like if let's say you're out of your 500 gigabytes that you've contributed to the network, let's say that 500 gigabyte makes up like maybe let's for instance in real life, let's say like maybe 0.3% of the entire network, right? So you are incentivized on the block side of it, on the block reward at that rate, zero point 0.3, right? So the more storage you commit to the network, the more rewards you get. So the network share, that's what I was trying to explain. To a miner with like 1% of the network, assuming you can contribute an entire 1% to the network, you would actually earn an equivalent of 1% for every block reward, right? So, and then of course, you have your proof of replication, which is generated when you commit your space, and then the proof of space time when a data is actually stored in these committed areas. So the rewards for proving they reward miners for proving Filecoin reward miners for proving that they are storing data uniquely and reliably. Yes, so combining all of this, Filecoin actually is that's the reward system for miners that are contributing their node to the network, contributing their hardware to the network. Yeah, I think I took a look at the simple analogy here. So yeah, so I was saying, looking at like if if a contributor, a miner contributes like 32 gigabyte or GB byte per sales sector, and then contributed to like five sales sectors, right? So in total, you've contributed like 160 gigabytes of your storage to the Filecoin network over five sectors, right? So for every sector, you are contributing 32 gigabytes. You could also choose to contribute 64 gigabytes per sector, depending on how much space you get or you have available, right? And then for these five sectors in this example, let's say the block reward per block is 10 field, right? And then this miner is contributing to five sectors, and then maybe the combined network is like 500 gigabytes, right? Or sorry, the combined sector is like maybe 500 sectors, right? So that means that with 160 gigabytes, this our miner here has contributed to an average of 1% of the entire network, right? So that means for every block added to the network, our miner receives 1% of it. So in this example, it's a rough example, say 10 field per block, so our miner is receiving 0.1 field per block. So remember, this goes across to every miner contributing to the network, depending on how much storage you've committed to the network. So yeah, the assumption here was 500 sales sectors, and then miner contributed 160 gigabytes over five sectors, which tantamounted to about 1% of the entire network. So for every block added to the network, our miner is receiving 0.1 field for that. So this is just basically a simple calculation of how miners rewards are calculated. On the block side, this is outside the market fees. Remember that the market fees deals directly with when a user stores data. So that incentives is quite different. This is for actually contributing and committing storage and adding blocks to the Filecoin network. Yeah. So, what are the implications of all of this? So, the implication of all of this basically is that it incentivizes um, miners to allocate their hardware for storage, right? So the more sectors that the miner contributes, the higher the chance or the higher the reward the miner gets, because the more space you commit to the network, the more rewards you get, depending on the total contribution you are contributing to the network. And then, of course, this allows for easy proof of replication and proof of space time, because once a miner generally contributes to the network by committing to a sector or multiple sectors, this automatically generates the proof of replication, right? And then when data is actually stored in that committed sector, right? So when data is actually stored there, then the miner already starts receiving the market fees, right? So the market fees is generated when data is stored. But even when data is not stored, right, contributing to the network allows you to also benefit from the block rewards, right? Depending on how much space or how much space or yeah you commit to the network, right? So this also allows for pure decentralization because the rewards are proportional to the storage, right? So there is no favoritism, there is no will when it comes to contributing to the network. It's just if you want to be a whale, you just have to contribute more space or more sectors to the network, right? So the more you commit, the more your rewards. I don't know if we have any question. Let me see. I'll go back. All right, well, good. Okay, so yeah, so with this, of course, we don't need to go back and forth, but basically, we can see that this allows for security in the Filecoin network because each sector is unique, right? So every time you commit to a sector, it's unique because you generate a proof of replication, right? That you have committed so amount to the network. So every network, every sector is actually unique. And then with the proof of replication, it means that storage is uniquely dedicated, right? So when somebody stores or when a user stores or sends data for storage, minus you like for instance somebody might store like the data and then copy the data and then maybe copy the data multiple times on their node to claim that they actually are storing like and so copies of the data. Remember when we talked about the redundancy factor where a user gets to determine how much replications they want their data across the network. So what would stop a miner from basically just getting one data and then copying it across his node and claiming, right? What stops that is the proof of replication because for you to actually store the data, you must first commit your storage, right? You cannot store data on a storage you have not committed. So once you store data on that storage, the proof of replication is generated, and then the proof of space time tells how long you have contributed your hardware towards storing this data, right? Remember, this data is stored it's a peer-to-peer system, right? So how long you yourself contribute to the storage of this data determines is determined rather by the proof of the space-time, which um, concurrently checks to ensure that the committed storage you've committed is storing the data, right? Remember that the sector is unique, and then when you store data, it generates a unique proof of replication. So the proof of space-time basically is checking since the last time this particular, because for every proof of replication, right, it will definitely have some form of ID to um, uniquely identify it, right? So it's constantly checking that particular one from the last time it was created or generated. How long has it been? Remember, the user also specifies the duration time they want their data to be stored, right? So the proof of space time determines, or rather proves that your committed your committed sector is actually storing the right data over the right time. Yeah. So, comparing this with other consensus model, I think this is pretty straightforward. We have proof of work, which is CPU intensive, right? So basically, like Bitcoin and every other proof of work blockchain, um, generating the proof of work is actually energy heavy because it's compute heavy, so it uses a lot of energy, right? And then that would be like a barrier for people that do not have access to energy or sufficient energy in some parts of the world to actually contribute to the network. That would be a barrier, right? And then when we come to proof of stake, of course, it's much more faster and efficient because it doesn't consume energy. But then there is the barrier in finances, right? Not everybody can afford some certain amount to stake to be able to have voting powers or to be able to benefit or contribute to a network, right? And then the Falcon approach is quite straightforward. If you have storage capacity, just contribute your storage capacity. You're not computing, you're just providing storage, right? And then this is more energy efficient, and then there is actually no barrier as long as you have like a hardware that has some memory space that you would want to contribute to the network. So it's a decentralized world, so anybody can actually contribute from any part of the world. I mean, your old laptop that you've not opened in a very long while. I mean, if you have like one or two of them, you could typically just use that memory and contribute to the Filecoin network and then gain some rewards out of it. So it's that straightforward. Anybody can participate. Right. So yeah, the real world impact and then some of the future prospects. Of course, this is energy efficient, right? Because you although you need electricity to like kind of like run your hardware, but you are not computing, so it's not burning as much energy as when you were computing. Basically, what you are doing is just providing storage, right? And then it's really, really scalable because any device that has storage unit in it can contribute to the network. So it means that it's really, really scalable. I mean, if you have a fraction of people that, in short, phones, how about phones? Like if you have memories on phones you have not been using for a long time. I mean, like I see a situation where we could gather old phones, just get the memories from them, and then have good amount of memory. You just use that as your network, or rather as your node in your house or somewhere. Give it a little electricity. It won't burn as much electricity because it's not really doing anything. It's just sitting there to contribute storage, right? So it's really, really scalable, and then anyone could be incentivized from there. But then, of course, the potential challenges to ensure incentive compatibility. Falcon actually solved this problem because it's really straightforward from the get-go. The amount of storage you commit to the network determines the incentives you get from the block side. And then any data that is being stored on any sector that you committed your storage to, it generates your proof of replication. And of course, with your proof of space time, you get incentivized for contributing that storage to the network. And then, of course, this is going to explode because everybody we are already aware Web3 is the next, not the next. It's already the biggest thing. And then imagine like having, we haven't, I don't Web3 native, so we are still a quarter or a fraction of the world. So imagine having like half of the population in the world that are come into the Web3 space, not only come but become Web3 natives. I mean, this could blow to a lot, right? Providing, imagine everybody contributing, like every household having one way or the other. There would always be a device you can contribute to the network, and then you are incentivized for contributing. So instead of just buying electronics and then spending money on them, you could actually convert some of your electronics to run or to contribute to a decentralized network, and then you get incentivized for it, just like Filecoin, right? So I think that's pretty much covers our basic maths for today. I'll take some questions. um, yeah, thank you for having me. So let me go back to check if we have any questions. Do we have any questions? Explain the number four again. I don't get number four. Let's see. Is it this number four? The potential challenges. Let's see. Oh, okay. Yeah, so the potential challenges, yeah. So, like I said, the potential challenge here is when you consider, when it comes to like, okay, let's consider what we have in the current Web2 space. Most of the storage providers we know, they are mostly centralized, yes, but how many of them, how many of them properly incentivize? Like some of these people, they run us in remote places, right? They run it where they have in remote places where number one, I think they'll have cheap electricity, they'll have cheap labor. Most of the big companies they do that, and then here you see a big barrier because they are more on the capitalist side of things. They are minimizing, um, how would I say, production, but maximizing profit, right? So in these remote places where they run their servers, how do they incentivize people there, right? How do they incentivize people that contribute, people that work for them? So Falcon here has solved this problem basically by saying you don't even need, there is no KYC, right? So if you have a hardware device that you want to contribute some space you are not using to the Falcon network, you can easily do that. And then the system automatically incentivizes you for doing this without much hazard because from the get-go, it is specified that, okay, to contribute to the system, you need to commit your storage. So once you commit your storage, it generates a proof of replication, right? And then this your storage combined with other people that have committed their storage, right, provides the storage that Filecoin uses or that users use to store file on the Filecoin network, right? Don't know if you get me. So basically committing your storage to the network, you are adding to whatsoever has been there. Everybody is adding. You don't need to, you can add all of your storage. You can add a certain amount of your storage. So, but basically, everybody that has contributed to the network is incentivized based on the amount of storage they contribute. So, incentivizing people here is very, very compatible because there is no case of A is working and B is taking away all the money, right? So if A contributes a higher sector than B in terms of providing storage, A is definitely going to get, in terms of the block rewards, A is going to get higher. And then in terms of the market fees where the user actually pays for that. So of course that is distributed again amongst everybody that contributed their storage to that particular sector, right? So basically files are stored in sectors, right? So every sector comprises people that are, I think somebody's trying to say something. Somebody saying something. I don't know. Please, we are not speaking. Can you mute? But Banjo, I hope that kind of like explained or answered your question. Yes. Okay. So yeah. Do we have any other questions? Yeah. Do you have any other questions? Feel free to unmute, ask your question, or you can type it in the chat. Yeah. Okay. Banjo says yes. That's cool. Okay, I think in the absence of any other question, admin, over to you. Thank you guys for having me.